This single grid is the entire language of electronics. These are circuit diagram symbols, the shorthand every schematic in the world is built from. Right now, it looks like a wall of squiggles. It is not. Every symbol on this page belongs to one of 6 families. Learn the families, and a strange new diagram suddenly has a shape you recognize. So we're going to walk all of them. Every common component, grouped so they actually stick. Power, passives, semiconductors, switches, outputs, and the wiring rules that tie it together. 2 of these symbols fool almost everyone. They each get their own moment. Let us build the whole legend, one family at a time. Here is the map. 6 families, and that is the whole set. Power and sources push current into the circuit, batteries, cells, and the mains. Passives shape that current without adding energy, resistors, capacitors, and coils. Semiconductors steer it, diodes, transistors, everything built from silicon. Switches and protection open and close the path or break it when something goes wrong. Outputs turn electricity into light, motion, or sound. And the wiring conventions decide what is actually joined to what. One trick before we start. To read any symbol, look at 2 things, its shape and its connection points. The shape names the part. The little dots and stubs sticking out are where the wires attach. That is the entire method. Quick note before the tour. Every symbol you are about to see also lives in a free chart on the site. It is searchable. It is printable. It costs nothing. Keep it open in a second tab and follow along. The link is right below. Right? Family 1. Family 1, power and sources. This is where every trace begins. First, the battery. A stack of long and short lines. Long is positive, short is negative. A single long-short pair is one cell. Repeat it, and you have a battery. Next, the DC source. A circle, often with a plus and a minus inside, feeding steady current one direction. Then the AC source. The same circle, but with a little sine wave drawn inside it. That wiggle means the voltage flips back and forth. And finally, ground. 3 shrinking horizontal lines, or a small triangle, marking 0 volts. Is the reference everything else is measured against. Some grounds mean earth, a literal rod in the soil. Others just mean the common return. Same symbol, so read the label. Battery, DC, AC, ground. The fuel tank of every circuit. Family 2, the passives. They shape current, but they never add energy of their own. Start with the resistor, and the first symbol that trips people up. In American schematics, a resistor is a jagged zigzag. In European and international standards, the very same resistor is a plain rectangle. Same part, 2 completely different pictures. Learn only one, and half the world's diagrams look alien, so learn both. Add an arrow through that resistor, and you get a potentiometer, a resistor you can turn to adjust. Next, the capacitor. 2 parallel plates storing charge in the gap. If both plates are straight lines, it is non-polarized, fit it either way. If one plate is curved, or you see a plus sign, it is polarized, and wiring it backwards can make it fail. Then the inductor. A row of little humps, or a tight coil of loops. It is simply wound wire that resists sudden changes in current. Resistor, potentiometer, capacitor, inductor. For parts that push electricity around without ever generating any. Family 3, the semiconductors. This is where electronics gets clever, and it all starts with the diode. A triangle pointing into a flat bar. Current flows the way the triangle points and is blocked the other way. A one-way valve. Add 2 little arrows shooting outward, and that diode becomes an LED, a light-emitting diode. Bend the bar into a Z shape, and it is a Zener, a diode built to clamp voltage. Point the arrows inward instead of out, and it is a photodiode, which reacts to light. Now, the transistor, the switch and amplifier at the heart of every chip. The bipolar transistor is a circle with 3 legs, a base, a collector, and an emitter. If the emitter arrow points outward, it is an NPN. If it points inward, it is a PNP. The MOSFET is its modern cousin, drawn with a gate line sitting just off the channel. Do not memorize the pins yet. Just learn the outlines, triangle, arrows, 3 legs, gate. Once the family clicks, every semiconductor is a small variation on one of these. Family 4, switching and protection. These open the path on purpose or break it in an emergency. The simplest is the SPST switch, single pole, single throw. A lever that lifts off one contact. On or off, nothing more. Give the lever 2 contacts to choose between, and it becomes an SPDT, a changeover switch like the ones in 3-way lighting. A push button is a switch that only holds while you press it, a little plunger over a gap. Then the relay, a coil that, when energized, magnetically flips a set of contacts somewhere else. One small current controlling a much bigger one. On the protection side, the fuse, a thin line or a rectangle that melts and breaks the circuit when the current runs too high. And the circuit breaker does the same job, but resettable, a switch that trips itself. Switch, push button, relay, fuse, breaker. Everything that decides whether current gets through at all. Family 5, the outputs, plus a few useful blocks. This is the whole point of the circuit, turning electricity into something you can see, hear, or feel. The lamp is a circle with a cross inside it, glowing when current passes. The motor is a circle with a letter M, turning current into spin. A speaker is a little trapezoid, like a tiny loudhailer. A buzzer is a dome that makes sound. Then the thinking parts. An op-amp is a triangle with 2 inputs on the flat side and 1 output at the tip. It compares and it amplifies. Logic gates are small shields and bullets, each shape meaning and or not. And when a chip is too complex to draw pin by pin, it just becomes a plain rectangle. An IC block with numbered pins and a name inside. Lamp, motor, speaker, buzzer, op-amp, gates, and the humble box. The outputs and the brains. Family 6 is not really components at all. It is the wiring, the lines between everything. And it hides the single most misread symbol in electronics. Look at 2 wires that cross. Do they connect or not? The answer is one tiny dot. A solid junction that where they meet means the wires are joined. Current flows between them. No dot, or a little hop where one wire arcs over the other, means they simply cross and never touch. One dot changes the entire circuit. Miss it, and you have wired something completely different from the drawing. So whenever wires cross, check for the dot first. Last, net labels. On a busy schematic, a wire does not have to be drawn all the way across. It just gets a name, a label like ground, or 12 volts. Any other wire with the same name is the same node. Same label, same wire, even on the far side of the page. Dots, hops, and labels. That is how a schematic says what is truly connected. So where do you find all of these when you need them? Right here, in a free editor that runs in your browser. Open the symbol library, and every part we just covered is one search away. Type resistor, or transistor, or relay, and there it is. Over 400 symbols, ready to drop straight onto the canvas. This is the honest way to learn them. Do not just watch. Open a blank diagram, search for a symbol, place it, and wire it to the next one. 10 minutes of building beats, an hour of memorizing. Everything you have seen is drawn in this exact tool, and it is completely free. So here is the whole legend in one breath. Power and sources start the circuit, batteries DC, AC, and ground. Passive shape it. And remember, the resistor wears 2 costumes, the American zigzag and the international rectangle. Semiconductors steer it, diodes, LEDs, and transistors. Switches and fuses decide what gets through. Outputs turn it into light, motion, and sound. And the wiring is where one junction decide what is really connected. 6 families. Every common symbol slots into one. A diagram you have never seen before is no longer a wall of squiggles. It is a language you now read. Open circuitdiagram-maker.app, pick any diagram, and start reading. It is free, it runs in your browser, and the link is right below. Subscribe if this finally made schematics make sense, and I will see you in the next one.